Okay, this is the Math 1113 Zoom meeting for September 15th, Math 1113. I did not get a chance to make the little video about the assignments yesterday, so I thought I'd go through that today. It's just one page, pretty self-explanatory. We're doing sections 5.2 and 5.3 this week. The 5.2 practice problems, page 453, 3 to 49 odd. 5.2 practice problems, I said. 3 to 49 odd. The 5.3 practice problems, page 465, problems 5 through 55 odd. Again, not directly for a grade. Quiz 4 on Friday. We'll cover these and be directly over them, and we'll have it available Friday and due on Sunday. Web assigned problems. Look at your personal study plan, practice quiz, section 5.2. Problems 1, 2, 3, 4, 5, and 6 only. In 5.3, 1, 2, 3, 4, and 5 only. That gives 11 problems on web assigned this week. And I've abandoned the Google Forms to report your answers. Just email me the percent of all these problems you get correct. So the percent of 11 that you get correct. Get all 11 correct. Tell me you got 100, and I'll write it down. Just send me an email, and I'll look through the email and write down the percentage of these that you tell me you got correct. But you're still self-reporting, just do it via email. I emailed out a grade report to everyone, and I had a short email explanation of it, but I didn't know if it would help if I talked my way through it. Here is a printout of a random student. Every grade category we have has its own column, and grades we have not taken yet have a 70, and that's to be a placeholder grade, assuming you pass those, so I can give you an average at the bottom. So right now, the proctored test grade, I've said it's 70, and the final exam, and the final exam will stay at 70 till the very end when we take the final exam. And so we have one non-proctored test grade at the moment, 3 quiz grades, and actually 4. I just collected the other ones last night, but haven't had a chance to punch them in, and 3 web assigned grades. These are the percentages that each of them count. The averages of each column are at the bottom. I'm wiggling this around too much, but it's hard to hold it still. Can't get it all on one screen. The equation to produce your grade is there, kind of written it out in English with each percentage beside every grade average. The grade you need to take on the final exam to make an A, B, or C, I give you that in 3 lines. So this person's not doing very well. They would need a 369 on the final to get an A, a 269 to get a B, and a 169 to get a C. So since the final goes from 0 to 100, they're not going to get either an A, B, or C if the semester ended today. You can take this number at the bottom to be your current average in the class. Again, based on the assumptions of 70s right now for every grade we haven't taken. The letter grade will stay blank until the very end when we take the final, and I will mail out the report and put the letter grade here at the bottom, and that's the letter grade that I intend to turn into Banner Web. Look for zeros and see if there's a 0 up here. If that's an indication you haven't turned it in usually, but if you think you've turned it in, and I have a 0 for it, well, send me an email and I'll double check and investigate. So that's why we publish this record, so you know what I think you have for your grades, and everything is transparent. There's no mysteries. Hope this helped. Charge into some of the homework then out of the book. 5.2 is about trigonometry of right triangles. Hope you remember that a right triangle we refer to as a right triangle, has 90-degree angle, which means two legs are perpendicular. So hope everybody remembers you have leg, hypotenuse. A lot of times they use A and B, and this is C. And I hope you remember that A squared plus B squared then equals the square of the hypotenuse squared. Now, they can call these legs and hypotenuse anything they want, and in fact, we are going to use them off the unit circle. This is the basic diagram we're going to use a lot. R equals 1, so the coordinates here, 1, 0, that's at 0 degrees or 0 radians. 0, 1, that's at 90 degrees, pi over 2. We went over these angles in 5-1. This is negative 1, 0. And at pi, and you're 180 degrees. And then down here, you're at 0, negative 1, and you're at 270 degrees and 3 pi over 2. And trigonometry relates these angles to these coordinates. Which are lengths of sides of triangles. Call that a ray, and I swing it at any point. It's one here, it's one here. You drop a vertical, and you have an X leg, and you have a Y leg. And we usually use this equation. Your X leg squared plus your Y leg squared always totals 1 squared, which is 1. You can do it in the first quadrant. You can do it in other quadrants. That's your X leg, that's your Y leg. Notice the X leg here is negative. Y is still positive. And in fact, if I did the same, be real careful to make these angles the same, I'd have the same lengths of legs. Down here, that's your X leg. This is your Y leg. X and Y negative. Both negative, and if I did it in the fourth quadrant, went back from a right triangle, that's your Y leg, this is your X leg, X positive, your Y is negative, you're in quadrant 4. Okay, you can quickly see how quickly the diagrams fill up and turn to gibberish. But there are to relate the angles to the sides of the triangles, which are the coordinates on the unit circle. This is off page 448. They give you this diagram. They put the angle here. They label this adjacent. opposite. If you had some trig in high school, this shouldn't be anything new. And this hypotenuse. Hypotenuse is always across the right angle. And they have three main functions. They write it this way. Here's the math gibberish. This is read the sine of angle theta. They use this cosine and this tangent of theta. And these are fractions. Ratios of the sides. So I'll write them down here. Sine theta. I'll abbreviate so I have to write out all the words. The opposite side to the hypotenuse. Cosine of theta, cosine of theta, the adjacent side to the hypotenuse. Got just barely enough word. Get the tangent in, the opposite to the adjacent. There's three others, usually they don't have it quite organized. Well, they've got it organized vertically. I'm used to organizing it this way. They flip it. This is read cosecant. And it flips the sign. So this is equal to hypotenuse over opposite. Secant, it's read secant. Hypotenuse over adjacent. Flips the cosine. Flips cosine. And cotangent, adjacent over opposite. Flips the tangent. Those are the three ratios you need to know. And we're going to translate them again back to the unit circle. The book makes a distinction in chapter 5, doesn't really talk about the unit circle. I talk about it all the time because to me they're inseparable. I don't like to make a distinction between non-unit circle and unit circle. To me, they're the same thing. All you got to do to put this in a circle is make an X and Y axes. And presto, you're swinging around a circle. And if you do that, chapter 6 will be just a direct follow from chapter 5. There's really nothing new in it. It's almost a complete review of chapter 5. Now, just to just work a problem before we talk about the three special angles. So page 'Homework example. Not a homework example. This is off the homework. 453, say the first one is number 3. They try messing with your head a little bit here. Put the right angle there, put the theta up here, 5 there, 3, and 4. Just to show you. Go off page 453, first homework. Number 3. Okay. I want you to find the values of the 6 trig ratios. The 6 trig ratios. Okay, the first thing to understand, because I met people who don't understand this, these numbers are not randomly chosen. If that's a right triangle, 3 squared plus your 4 squared, the two legs have to add to the hypotenuse squared, or it's not correct. You see 9 plus 16 equals 25, and sure enough. So they don't just randomly stick numbers on here and just have you write down the fractions. All the numbers they give you for a right triangle have to work like this. It's been known since 2000 BC, Pythagoras. Okay, and so I organize it this way, and if you want to use the previous language, that's going to make this adjacent, that's going to make this opposite the angle, and of course this is hypotenuse. So if I write down the sine of theta, I'm going to have opposite side to hypotenuse 4/5. If you want to go ahead and flip it, it makes the cosecant 5/4. If you get the first column, the second column is just the flip. Cosine theta then is your adjacent over hypotenuse. Has anybody joined us? No. So that would be 3/5. Your secant, 5/3. The tangent is then opposite over adjacent would be 4/3. Opposite over adjacent. And your cotangent, 3/4. And with these numbers, I think I can point out the absolute rules of trigonometry. Your sine and cosine are the legs. This is the y leg on the unit circle. This is the x leg. I'm trying to get you used to this. They are always, I'll write down your sine, cosine, always less than or equal to 1. They can be 1. If equal to 1, they're on an axis. They're on an axis. Otherwise, they're always less than or equal to 1. So occasionally, when we get into decimals, somebody will go, well, a sine of an angle, doggone, and it's 3. Okay. You're screwing up. It's never bigger than 1. Ever. Now, there are no such rules for tangents. Your tangents are the ratio of the legs to the triangle. These are the legs of the triangle, and the tangle is the ratio. So notice this one is tangent's bigger than 1. That makes the cotangent less than 1, and it can be vice versa. It just means that your y leg is bigger than your x leg. I always think of it that way. No rules at all. No rules for tangent or cotangent. Okay, so that's where the section starts. We'll go through some more homework in a minute, but let me try to explain that there are about the three special angles. There are 3 special angles. And if you understand, there are 45 degrees and 60 degrees. If you understand why these are special, you know about 90% of trig. If you get what's the big deal about these 3 angles, and again, I like to explain it off the circle, even though they're not talking about the circle here, but they are talking about these angles. They're talking about them on page 449. your special angles, and they have 40, 5, 30, and 60. Okay. Off the unit circle. Off the unit circle. We'll do 45 degrees first. 5 degrees first. Like we said, you start with the ray. If you swing it up, you're one there, you're one there. This is all X leg with coordinate 1, 0. Notice as I swing, X leg gets shorter. There's the Y leg is 0 here, and I get a Y leg and a Y leg shorter. Y leg gets longer. If you go all the way up here, pretty close to the Y-axis, you're getting pretty close to the Y long, and see how short your X leg is getting? And see, at the Y-axis, you're all Y leg, 0, 1. There's no triangle at all. You just got a line. That's what I was trying to say. If you're 1 with one of these, you're all Y leg. You have no X leg, you have no triangle at all. You're on an axis. All right. Anyone want to guess what magic things happen at 45 degrees? You're halfway up to 90. At 45 degrees, your X leg and your Y leg, see below there, below 45, your X leg is greater than your Y leg. Or your Y leg, see, trigonometry is a very physical thing. You can see things. Your X leg is a lot longer than your Y leg. Go above 45, and look how long your Y leg is compared to your little short X leg. Above 45 degrees, your X leg, I'll just leave it the same order, your X leg is less than your Y leg. So what magic things happen at 45 degrees? At 45, your X leg equals your Y leg. Remember, X squared plus your Y squared equals 1. So if I'll rewrite it up here, X leg plus your Y leg equals 1 squared, or 1. Set, so at 45 degrees, set your X equals Y. You can plug in for either letter. I guess I'll keep them X, or Y equals X. So that gives me X squared plus X squared equals 1. Well, these are like terms. That's 2X squared. Divide by 2. X squared equals the square root of 1/2. Square root of 1 is 1 over square root of 2. Square root of X squared. All right, so that means X equals 1 over the square root of 2. They like it rationalized, so we multiply by square root of 2 over the square root of 2. That gives you square root of 2 on top. And root 2 times root 2, the root cancels and you get 2. And since Y equals X, your Y is the square root of 2 over 2. This means the lengths of the legs at 45 degrees is or R, I guess, to correct English. 45 are root 2 over 2 and root 2 over 2. So these are coordinates. Coordinates. $45. Coordinates there are root 2 over 2 for x and root 2 over 2 for y. If I drop and form my triangle, this leg is root 2 over 2, and this leg is root 2 over 2. And you got to be able to swing around to any other quadrant, and all that does is change the signs. So at 135 degrees, your 45, call that the 45 equivalent, drop. Your coordinates go negative root 2 over 2, but your y stays positive at root 2 over 2. If you go down to the third quadrant, again, 45 in, you'd be at 225. They both turn negative. Again, these are right triangles with 45 equivalent. You're at negative root 2 over 2 and negative root 2 over 2. They're both negative. Notice that the x legs match. The y is turned negative because it's down. And in the fourth quadrant, you're at 315. And that is 45 from each axis. And your x has turned back positive, matching this, but your y has turned negative, matching that. Or I'm sorry, opposite side of that, because it's down. So that's what you should get off of 45. Okay, we'll look in the homework where this is going to show up. Let's explain why 30 and 60 are special. And this is where maybe their diagram on page 449. This one's much harder to see off the circle. So page 449, 30 degrees and 60, you kind of explain them together. And it starts with an equilateral triangle of side 2. An equilateral triangle, side 2. Equilateral means all the sides are the same from geometry. Drop a line perpendicular and you form right triangles. And everybody understand has angles of 60 degrees. Remember, all the angles of a triangle must total 180 degrees. All angles of any triangle total 180 degrees. So 60, 60, 60, 120. That means they've got to be 60 total. I'll write it out here. Because when you drop the perpendicular, it's going to make this side 1, this side 1, and there's 30. I'm losing the degree symbol. Okay, and that is this diagram. Right here. Okay, now, where's the darn root 3 come from? Well, from the Pythagorean theorem. Call this, we'll call it U. It's just an unknown right now. We're pretending we're not on the circle. You can use either half, but that U squared, in other words, to find the vertical leg, plus 1 squared, that's the total 2 squared, because 2 is the hypotenuse. U squared plus 1 equals 4. U squared then equals 3. Subtract the 1 over. Square root of U squared equals the square root of 3, and U is the square root of 3. Don't need the plus and minus. On a general algebra equation, you would need the plus and minus if it doesn't mean anything. But these are lengths of sides, and we drop the negative. Don't need the plus and minus. So that's where their root 3 comes from in the middle. Equals square root of 3. Okay. And then you just write down your ratios. You can use either half. Use either half. 30 degrees. Sine 30 degrees. Opposite over hypotenuse. 1/2. And that's opposite over hypotenuse. The cosine of 30 degrees. Adjacent over hypotenuse. So adjacent side on 30 is root 3, hypotenuse is 2. Tangent, 30 degrees. Opposite over adjacent. Okay, it doesn't really like these non-rationalized, so to get rid of the root 3 on the bottom, that'd be root 3 divided by 3. You can leave a root on top. These are the special values at 30 degrees. The other 3, just flip them. 30 degrees would be 2 over 1. Secant, 30 degrees, 2 over root 3. And again, we don't like that root 3 on bottom, so root 3 over root 3, that would be 2 root 3 over 3. You can't really do much with that. Your cotangent, 30 degrees, would be 3 over root 3. Again, rationalize. And you, this 3 cancels it. You get root 3. All right, let me explain what this means on the circle. Maybe I can do it really briefly over here on the circle. This simply means if I go up 30 degrees, my coordinates, you can read this, are going to be 1/2 and root 3 over 2. Kind of jumping ahead, your sine of an angle is always the y leg. Your cosine is always the x leg. Root 3 equals 1.73. So notice that means all you got to do is just twist this around. You can see if you twist the triangle around and try to line it up, that means your y leg's 1/2 and your adjacent leg is root 3 over 2. Again, remember your radius is 1. Up here. Notice how you're below 45. So your x equals root 3 over 2 is greater than your y, which is 1/2. Your x leg is longer than your y leg. What it means at 30 degrees, God, I wrote that backwards. What an idiot. Stuff is confusing enough without me screwing up. That should be root 3 over 2 and 1/2. Your x leg at root 3 over 2 is greater than your y leg of 1/2. We won't be sending this tape to the Teaching Hall of Fame. I wonder if anybody's going to watch it this deep into it to see where I screwed that up. Okay. So this means, what was I going to say? Diagram's getting all, maybe I should go ahead and do it on the next page, just bigger. At 30 degrees, Your x leg is, adjacent leg is root 3 over 2. Your y leg's a half. Your coordinates are root 3 over 2 and a half. And if you go around the other quadrants, write them all in, but this means you're at 150 degrees. Maybe I should write it up here because this little part is 30 degrees. You see you've switched your negative root 3 over 2 and positive a half still. You're still matching this, making your coordinates negative root 3 over 2 and positive a half at 150 degrees. Let's see if I remember that. That would be 5 pi over 6. 5 pi over 6. How do I know it's 1 pi over 6? 30 degrees is pi over 6. Hope you have all this stuff memorized. If you go to the other quadrants, so that's 30 degrees. You are at 210 degrees. Your x leg still matches and your y leg slipped down a half. So your coordinates are negative root 3 over 2 and negative a half. And if you do 30 degrees off of this one, your x leg is common, so that's identical. But your y leg is slipped down negative a half. Negative a half. And you're at 30 short of 360, which means you're at 330 degrees. I don't have all this stuff memorized either. I just know the basic concept off the first quadrant, and then I'm able to swing it around. I know what equivalents they are, and I can swing it around and change the signs into the other quadrants. It's the secret to it. 60 degrees. I'll redraw half the triangle. So boom, boom, boom. I'm redrawing this. Root 3 was here. This is 60 degrees. That was the full angle. That's the right. And you're at 2. So when you do sine 60 degrees, opposite over hypotenuse, root 3 over 2. Cosine 60 degrees. This was 1. You're at 1/2. Tangent, you're at root 3 over 1. 60 degrees, the values are flipped from 30. Notice the sine of 30 was my 1/2. The cosine of 60 is my 1/2. I'll explain this around the circle and you can see how it makes total perfect logical sense to me. Cosecant of 60 then is flipped, 2 over root 3. Root 3 over root 3, that would be twice root 3 divided by 3. Your secant of 60 would be 2 over 1. Cotangent would be my 1 over root 3. I believe that worked to root 3 over 3. Again, I'll draw these on the circle. Just to compare them, I won't put 45 on. Well, maybe I should in the first quadrant just to compare them, but what we've got now is 30 degrees. We said this was root 3, I'll do it right this time, and 1 up a half. 45 degrees, you're at root 2 over 2, root 2 over 2. And at 60 degrees, At 60, your values flip. Values flip from 30. So in other words, you're at short leg a half and y leg root 3 over 2. That's at 60 degrees. If you remember, that's pi over 3. Pi over 2, pi over 4, and pi over 6. You can see it, trying to draw it real exaggerated. 30 degrees, your x leg's a long leg. That's your root 3 over 2, because root 3 is bigger than 1. And then they flip, the sides flip around 45, and your y leg has grown bigger to be equal to what your x leg is at 30, root 3 over 2. And your x leg is shortened up to a half. And of course, by 90, you're at 0, 1. Your x leg is shortened back to 0. Your y leg's 1, whereas at 0 degrees, your all x leg is supposed to be on a circle. You're at 1, 0. Your all x leg at 1 and your y is 0. But at 90 degrees, your y leg has grown up to 1 and your x leg is shortened back to 0. Just to do the 60 around in different quadrants. So this is 60 degrees. Over here, you see how your y legs are identical, but your x leg has gone negative. You're at negative a half, positive root 3 over 2. Down here, your x legs are going to be identical. They're both going to be negative a half and negative root 3 over 2. Because it's not negative. This up here is positive root 3 over 2. Down here it's negative root 3 over 2. And you come over to this quadrant, and your y leg matches negative root 3 over 2, but your x leg's turned back to positive a half. So you're at positive a half, negative root 3 over 2. See how your y leg is turned upside down. Values around, let's see, you'd be at 30 from 9, so 90, you'd be 120 degrees total from here. 180 here, so 180 adds 60, you're at 240. Just 30 from 270, remember this is at 270. And then you're at 60 from 3, so you're at 300 degrees here. There's two measurements. There's the equivalence inside the quadrant they keep between 0 and 90, and then there's the total angle all the way around to that number. So this is 60. Okay, well that makes perfect sense to me. Let's see, I got just enough time for a few homework problems. That's the kind of numbers and values they expect you to know and remember in trigonometry. Back to the homework. Okay, we did number 3. And number 9, this is off page 453. They switched kind of symbols on you. They put they use a lot of Greek symbols. This is called a beta. This is called an alpha. They put a 3 here and a 5 here. See, your hypotenuse is not 4. They don't ask what it is. I'll just do part A. They want find sine alpha and cosine of the beta. Right here. Sine alpha, cosine beta, and here's the way the triangle looks. Okay, I meet people, they'll get confused. They're so used to like 3, 4s, and 5s around a triangle, they put a 4 over here as the hypotenuse. It's not the hypotenuse. You got to find your hypotenuse. I don't know, you can call it C or A, H for hypotenuse. I mean, But your 5 squared add 3 squared has got a total c squared. 25 add 9 equals c squared. Again, even though these individually have roots, do not take the roots and add them up. It's not the way it works. You got to do the whole root of the whole thing equals c. And that's 34. Your c is root 34. Square root of 34. You just leave it root 30. You don't have to get the decimal for it. If it works out like root 36, yeah, you write 6. If it works out a perfect whole number, go ahead and do it. But if it's an odd thing like 34, you just leave it root 34. All right, so your sine, part A, your sine of alpha, remember that's opposite over hypotenuse. Well, to the alpha, the opposite is 3, and your hypotenuse is root 34. Now, you could rationalize things. I don't make you do it. You can just leave it like that. Leave alone. If the book answer doesn't look like this, then they've rationalized it. And your cosine of beta, that is adjacent over hypotenuse. Your adjacent is 5, and your hypotenuse is root 34. And notice these are less than 1, as they should be. Root 34 would be a decimal number just less than 6. So it's bigger than 5. Okay, try problem 11. Part A, sine 22 degrees. Okay, when you use a calculator, I'm going to read this. If degrees, use degree mode. Off the thing. Degree mode. If you go to your calculator, mode button is right here. You got a different calculator, have a different thing. Third line down says radians, degrees. Graphs are nearly always done in radians. But individual little arithmetic, this angle is in degrees. I went too far, so back up, 2 degrees, enter. Okay, if you get out, then back in. Now my degree mode is lit, and I'll get the correct number if I punch sine. Your sine, cosine, and tangent buttons are all right there directly. 22, it takes the 22 to be in degrees in degree mode. Sometimes I write these to 4 places, 0.3746. I'm short on time right now, so I won't mention at the moment exactly what that is, but it does have a physical meaning. But I'm trying to get to a few more examples here real quick. Try 15. And we'll have on Thursday get to problems in 9 and 5.3. Just a lot of stuff to explain right at the beginning of trigonometry. Try 15, page 453. X and 30 degrees. And they want you to find X. So here's an example of using your ratios to find an unknown side. And you read this as opposite, and this as hypotenuse. The direct ratio for that was the sine. Is equal to X divided by 25, opposite over hypotenuse. Solve, clear the fraction, multiplied by 25. 25 sine 30 degrees is equal to 25 times X divided by 25. 5's cancel. And again, we're in degree mode because the 30 degrees in degree mode. I can just punch it all at once. 25 sine 30 degrees. Comes up 12.5. Gee, how can that be? That looks like half of 25. Yeah, if you remember, sine of 30 degrees by itself was a half, if you'll flip back a couple pages. So yeah, by itself, this is a half. Half of 25 is 12.5. Okay, maybe time for one more. Try 23. Page 453. Tangent theta over 6. Sketch a triangle. Find the other values. Okay. I always kind of make my triangles kind of look the same. And I know that this is opposite over adjacent with a tangent. Theta here, opposite would be 5, adjacent would be 6. I'm gonna have to speed this up because I got to get to my 9 a.m. Zoom meeting. Hypotenuse then, h squared is 5 squared add 6 squared. H squared would be 25 add 36 plus 36, 11, 61. 61, so h is the square root of 61. And find the other value. I'll keep the same table. That makes a sine. I have to speed this up. Opposite over hypotenuse. Cosine. Adjacent over hypotenuse. Tangent, already written down. That was given. That's 5 over 6. And then the other three just flip. Secant theta, root 61 over 5. Secant theta, root 61 over 6, and cotangent 6 over 5. That might have made that look easy, but I'm in a hurry, so I'm going to have to end the meeting and get on to my 9 o'clock meeting. There's Setch, can't spell, sketch. So no other questions. We'll end the meeting. And on Friday, we will continue on through the homework 5.2 and 5.3. Very well, we'll end the meeting.